Okay, welcome back. It's time to do our last of the Newton's laws. We're going to take on Newton's third law. And this one here is actually less about math and more about concepts, just understanding. Newton's third law can be thought of as the reaction force law. Now, I'm sure you guys have heard the first phrase here. For every action force, there is an equal but opposite reaction force. But I actually find that there's a better way of explaining this one. And that is what you see in the box right here. If A exerts a force on B, then B exerts an equal but opposite force on A. So if A exerts a force on B, then B will exert an equal but opposite force back on A. Let me illustrate that with a kind of a basic scenario where you kick a soccer ball. Let's imagine you kick a ball with a force of 150 newtons to the right. And we want to understand how Newton's third law will actually relate to that. Well, let's start by analyzing the ball. So we'll draw the ball over here on the left-hand side. Now, do you remember, what are the only kind of forces you can put on a force diagram? And they are external forces. So if you want to show the force from the foot, you cannot draw the foot. The foot has to be external to the ball. So therefore, don't draw the foot. Then you can draw the action force from the foot. Here's the force that comes from the foot. And that foot force is 150 newtons. Now, really simple question for you guys. How do you know that force actually exists? What do you observe? And the answer is, we observe that the ball will accelerate forward. Because the ball accelerates forward, we know that it must have experienced that force from the foot. Good. So what we've actually seen so far here is that the foot exerts okay, sorry about that. The foot exerts a forward force of 150 newtons on the foot. And what we can do is we can do a little bit of a creative labeling here. We can call the foot A. Oh, sorry, and I actually, okay, I've got to make sure I think when I'm actually doing this. My apologies. This is on the ball. Thank you. Okay, there we go. I'm sure you guys caught that. So the foot exerts a forward force on the ball. So A exerts a force on B. But remember, if A exerts a force on B, then Newton's third law says that B should be exerting an equal but opposite force back on A. So if I divide my screen up here, we can first describe this force. Let's do that. So if B exerts a force back on A, that means that technically the ball exerts a backwards force. But it has to be equal but opposite. So it's also going to be 150 newtons on the foot. There's B exerts a force back on A. So B back on A. Well, that means that we now want to draw a force diagram of this. Now realize that this force is acting on the foot. This is really important. This is acting on the foot. That means that's what we draw. And bear with me, I'm just going to draw a really basic foot. Okay, not an art class. Okay, so, but imagine that this is actually the foot. And we're saying now that the ball will exert a backward force. This is the force from the ball, and it would be 150 newtons backwards. And the question, I guess, for us to finish this up is, how do we know this force exists? What do we observe? Well, a couple things we actually observe. The first one is there will be an acceleration going backwards. This actually causes the foot to slow down. because it's moving to the right, but it accelerates to the left, so the foot slows down. But do you also agree that you'll feel this force on your foot? So the fact you feel it means that there must be a force coming from the ball. Now this, what I'm showing you right here, is actually really important for one major reason. When you're dealing with Newton's third law, you got to realize, and I'm just going to highlight this for you here, that reaction forces act on different objects. Notice, one force, the action force, was on the ball, and the reaction force was on the foot. They act on different objects. Don't put them on the same diagram. They have to be on two separate diagrams. And that leads us to our first example. So here I have a boy and a girl pushing on each other. So the boy exerts a 500 Newton force to the right on the girl, and the girl exerts a 700 Newton force to the left on the boy. And we want to find the acceleration of each person. I recommend you guys pause and try this question yourself. Just see if you can draw the force diagrams on each of these people. Okay, let's start over here by just drawing the diagrams, just really simple diagrams. This represents the boy. And then over here, we can draw, I don't know if you want to add something to make it clear, but let's imagine this happens to be the girl. Good, and the boy has a mass of 80 kilograms. The girl has a mass of 60 kilograms. Now, if we draw the force diagram here, we start like this. We know the boy exerts a force to the right on the girl. Okay, so we're going to focus on that one first. A 500 Newton force to the right on the girl. That means that force is acting on the girl. So let's draw that one on the girl. Here's the force from the boy. And that happens to be 500 newtons. But remember, if the boy exerts a force on the girl exerts an equal but opposite force on the boy. There will be a reaction force on the boy. We'll just call it Fr. And that will also be 500 newtons, because every force has an equal but opposite reaction force on the other object. Okay, now let's talk about the second part of this question. I'll choose a different color than that. Now we know the girl exerts a 700 Newton force to the left on the boy. So here comes the force from the girl. And that happens to be 700 newtons. But again, if the girl exerts a force on the boy exerts an equal but opposite force on the girl. There's its reaction force, and that would also be 700 newtons. Do you notice, by the way, that they both experience the exact same magnitude of force? They both experience 1200 newtons of force. So remember, make sure you draw two separate diagrams when you're drawing that acknowledges Newton's third law. Now our job is to find the acceleration. And here's my question. If we're going to deal with acceleration, which law? An acceleration deals with Newton's second law. So here we have Newton's second law, which of course is F net equal to ma. So let's get the kind of acceleration by itself. So a becomes equal to F net over m. And I'm just going to do a really simple reference system here. Let's say to the right is positive and to the left is negative. Then we can see that the net force here on the boy will be negative 1200 newtons over the mass of 80 kilograms. So 1200 divided by 80 is 15. So this is negative 15 meters per second squared, or 15 meters per second squared left. Now, the girl experiences the exact same net force. Does that mean she will have the same acceleration? Well, let's find out. So for her, the acceleration will be positive 1200 newtons, F net, over her mass of 60 kilograms. And that comes out to be positive 20 meters per second squared, or 20 meters per second squared to the right. Notice she experiences a greater acceleration. And that should make sense because she has less mass. There's an inverse relationship between A and M. If you kind of look at the relationship here, A and M have an inverse relationship if F net is the same. So therefore, the smaller the mass, the bigger the acceleration. Good? Okay, there is one more question we're going to be doing, but it is an excellence level question, so I'll save that for one more video. All right, I'll see you then.